Yeah. Let me get this thing to focus. That's pretty good. Well, one test down and a few to go, huh? Oh, let me go through my list. Adrian's here. Taylor's here. Cammie's here. Brienne, are you hiding? Brienne's back there. Brendan. Oops. Black pen instead. Nick. Joanne. Rose. Brenda. Lindsay. Elizabeth. All right. Anything from chapter 8 so far? 8.1 with graphing. Anything in 8.1 that we need to look at? 4.3 was extra credit. So if you still haven't did that, get in there and do that. It should have been a review of graphing, hopefully. Or for those that have been away from graphing, it should help to pull that stuff back so you get an idea of what you do have to do with graphing for that. So that's the key piece there. Anything in 8.2? 8.2 was our second method for doing this material, and so that was the other piece that fit in there. And 8.2 was looking at using substitution and substituting a value in for a letter. So if you had a single y in some equation, you could take that and substitute it in for the y value in the second equation, solve for y, get that answer, go back, plug it in for x, get x's answer, and then put it in as a point, because it's a point location, making sure you put parentheses with that point. And then from there, you needed to check it, make sure it worked for both things, so that you got that cross value in there. Probably out of the two that we did on Monday, that one, not Monday, but last Wednesday, that would be the one that would probably be the easier of the two. The graphing one has the tendency to be a little technical and a little bit difficult sometimes to do that. Does everybody have the handout from last time? Anybody need that? Because we're going to work on story problems today. 8.4 is, do you need one? Yeah. That was from last. I don't know if you have that. Did you have that one, Brandon? Okay. So anyway, I wanted to make sure you had that so that we had this piece to add to it. So today we're going to look at the third method of working with these. And the third method is, I tend to like this one better than most. It tends to be the quicker of the hand ways of doing, or methods of doing this. We are next time on Monday, we're going to use your graphing calculator to do matrices. So make sure that you bring your graphing calculator with you. Very, 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 very important for Monday that you have your graphing calculator, because we're going to go through the keys that you need to solve these the fourth way, and that is using your graphing calculator to do those, because we get into a 3x4 matrix at that point. So we want to make sure that you have your graphing calculators to do those, because there's some changes and we're not going to do it the way necessarily that Hawks has you do it for those sections. So 8.3 is looking at linear equations solved by adding. And in this case, to solve the system of linear equations using the method of adding, and use systems of equations to find the equation of a line through two given points. So that's our goals for this section. And so we will start working with those. First off is our methods for doing these. And it says write the equation in standard form. Standard form means that it's in ax plus by equals c. That's standard form. So standard form, I need to have all my variables on one side and my constant term on the opposite side. So in other words, get all variables on one side. Then it says, multiply all terms of one equation by a constant and possibly all terms of the other equation by a constant, so that two like terms have opposite coefficients. Opposite meaning one is negative and one is positive. So we've got those capabilities in there. So we want one that's going to be negative and one that's going to end up being positive when we work with those. The final piece is add the two equations together, combining like terms, and solve the resulting equation. When you do this piece, what's going to happen in here is the one variable will disappear. So it's going to go away. It's going to disappear, and you'll never end up seeing it within that again. And that's the thing that makes this kind of nice, is because it does disappear, then what you can do is that you've got this whole piece that's coming together, and so you can work with it. And I know, again, these steps probably don't end up making too much sense right at the moment, but they will. And so then finally, substitute into one original equation and find the value of the other. So you're going to pick one equation and solve for the missing variable. So we're going to get and find the one that we may go away in that case. Then you're going to check the solution to see if both are the original equations and if it works for both of them. I know this doesn't sound like it's too easy, but in the long run, let me get this ladybug out of the way up here. It's going to work out easier. Actually, it's easier than all the other methods that we've worked with so far, because it actually has fewer steps to it. Okay. So we good to flip, I think? Okay. So if we got an example here of two equations, I'll give you a chance to write this one down first, because we will go through it and see what we can do with it. So first, I needed to make sure it was in standard form. Is it in standard form? What would you guys say? All variables are on the one side, all constant terms are on the opposite side. So we do end up having that situation taking place. So then we need to, second, see if we can get rid of a variable. So pick a variable to remove. So if I look at this and I have an x and an x, and I have a negative 2y and a positive 2y, my goal in here is to make one go away. If you look, one's negative and one's positive. So they must have opposite signs. And they do, right? So step 3 is add the two together. And what's going to happen when I add these two together is x plus x is 2x. 2y, negative 2y and a positive 2y, what happens to them? Cancel, they're gone. A negative 9 and a positive 11 will leave me with 2. And so now all I need to do is solve for the variable. So divide everybody by 2, and I find out x is equal to 1. So I have one piece of my problem. We good there, you think? Okay. So if I have one piece of my problem, I've got part of it out of the way, so that's pretty good. Now, step 5, solve for y in this case. So I'm going to take one, pick one of these. Which one would you want to pick for an equation to work with? Pick the first one or the bottom one. Why do you want to pick the bottom one? If I pick the bottom one's going to be easier because I got all positives in here. So I'm going to pick the bottom one. So 1 plus 2y equals 11 minus 1. So I get 2y is equal to 10. Divide by 2. And I find y is equal to 5. So my solution to this is going to be 1, 5. So that's what we found when we graphed these. So if you put those two equations by solving for y, plugged them into your calculator, and then did the intersection by going to second calculate and going up and using the intersection part, you would have found 1, 5 would have popped out as your answer. Okay, so that would have been the piece you had. So then finally, 6, check. So we're going to go back and check it and make sure it works. So if I put 1 in for x, minus 2 times 5 is a negative 10. So 1 minus 10 does give me a negative 9. We good there? And then the bottom one, 1 plus 2 times 5 is 10. And 1 plus 10 is also 11. So it checks. So it ends up working out correctly. Okay? So far, so good? Okay. All right. The second one that's on this page, if we look at that one, is it in the right format? So is it in standard form? No. So I need to get it there. So to get it here, I need to move this 2x to the opposite side. And when I do that and I add 2x, I end up with 2x plus 2y is equal to a negative 28. We good? All I did was move my 2x over. If I move the bottom one over, then what's going to happen here is I'm going to add an x to both sides. So I end up with x plus y is equal to a negative 14. So is that good? Okay. Can I subtract any, or can I pick a variable? Yeah, I got to pick one over here. All of them are both positives. You notice that? This top's positive, the bottom's positive. And so if I pick a variable to make it go away, what's going to happen? Well, I could pick x's to go away, or I could pick y's. It doesn't make a difference in here of which one you pick. Okay, so you could pick either one. So if I want to say, I'm going to make x's go away, what I would have to do to make my x's go away is I need to take that bottom equation. Get a different colored pen here. I need to take this bottom equation to make x go away. What would it have to become? Well, it would have to become a -2. We all agree? Because this is a +2, this one had to become a -2. So if I multiply every piece in here by a -2, what's going to happen? Well, a -2 times x is a -2x. -2 times y is a -2y. -2 times 14 is a +28. We all agree? Okay. Then I'm going to bring the other one that I worked with from up above. It's going to be the same one. I'm not going to change it in any way. And when I take these two and add them together, what happens? These guys go away, right? These guys go away. This goes away. So I'm left with 0, not 0, but yep, 0 equals 0. So this is a true statement. So back in, oh gosh, it would have been quite a while back, we had what was called conditional, where you had only one solution for your equation. So this one over here is kind of considered to be conditional because it has only one solution. We had unconditional, or we had, what was it called? Yeah, kind of unconditional. We had that one that had no answers and no solutions to it, and we had one that had many solutions. In this case, this one has many solutions. Because if we graph this on our graph with the graphing calculator, what would happen to these two lines from 8.1? I put on my calculator and I looked at those on a graph. What would they look like? Well, they'd be the identical lines. So these are the same lines. And because they're the same lines, the lines are right on top of each other. So if you graph this, you would have one line doing this, and you would have another line doing this. And these are not the graph of that line by any means. If you have that graph going on, they're on top of each other, so that's why we have many solutions, because there isn't just one answer to it. They're the exact same line, okay? So we showed that right here. Do I need to go any farther with it? Nope, I'm done, okay? When you did stuff in 8.1, of course, you had to get your y's all alone and put it on your calculator or put it into the system that you had at that moment. Or you had to, in 8.2, take this piece here, put it back in for y and solve it, and that's the same time you found that they were identical to each other and everything disappeared. So you found out that you had that situation happening. Questions with that one? Okay, so if everybody disappears, that's what happens. So let's look at another one here. Give you a chance to write that one down. So, we're going to try to figure out, is it in standard form? Yes, standard form, that's good. Got all the x's and y's on one side, and we know that it's in a standard form for that one. And then what we need in here is to try to get rid of a variable. So which variable would you like to make go away? Remember, you got to make them so they have the same number out here and opposite signs. Okay? So if I look at x's, I've got a -9 here and a -3 here. How can I make that x's disappear? What would I multiply it by? If this was negative and this is positive and it was a 9, I could make them go away. So I'm going to take the top piece, yep, and I'm going to multiply the top piece by just 3 or a negative, yep, a -3. So a negative 3 times a negative 3 is 9x. Negative 3 times 2y is a negative 6y. Negative 3 times 9 is a negative 27. And then if I bring the other one right straight down below it, and I add those two together, my x's go away. I'm left with a negative 3y, and I'm left with a negative 5 and 7 is 2, 1, 52. Divide by a negative 3. Oh, 42. Yep, you are right. It is a 42. Divide by a negative 3, and I find out that y is equal to negative 3 goes into 42. You guys out there, how many times does it go in there? 14. Okay, so y is 14. So I have one piece. Then I need to go back and figure out which one of the originals I want to plug 14 in and solve for y. So which one do you think we should pick? Does that make any difference? Absolutely not. Either one will lead you to what y is. So we go back. We'll just take the top one, I guess. Negative 3x plus 2 times 14 is equal to 9. Negative 3x plus 28 is equal to 9. Minus 28 gives me a negative 3x. And 9 from 28 is what? What was it? 19. Divide by negative 3. And I find x is equal to it's a negative 19, is equal to 19 thirds. Not a real nice number, but it does come out to be that piece that's in there with that one. So that's what we end up with for our two answers with this one. So 19 thirds and 14. So let's double check and make sure that we end up with what we're supposed to have. So if I take the first line up here and plug these two into it, I'm going to have a negative 3 times 19 thirds plus 2 times 14 should equal 9. So these threes cancel. This means negative 19 plus 28, and that equals 9 because that's the one we just used. If I plug it into this one, is it going to give me my answer? Does it? Okay, because the 9 and the 3 will cancel, so I'm going to have negative 3 times 19, and then 3 times 14, and when we subtract those, we should get negative 15 if it works out okay. All right? Think you got the idea? Okay, let's take the next one, and let's see what we get for this thing, and see what happens to it. So you guys work on it, and see what takes place with it, and see if we can all end up with the right answer when we get finally down to working through those. For this one, you have to multiply both lines by something to make something go away, because it's not going to go away with just one multiplication. So which letter did you pick? Y? Okay. So if we pick Y, we've got the same signs here. So we'd have to figure out what we're going to multiply it by. So one sign's opposite of the other sign. And so what would you multiply the top by? Top gets multiplied by -2. Elizabeth and Gavin. The giggles. I know. Yeah, but you got her giggling. And then what do we multiply the bottom one by? If we've got the top coming out as 10, because if we multiply 2 times each of these, or did we multiply by -2? I think we did. -2 times 3 is a -6x. -2 times 5 is a -10y. -2 times a -3 is a +6. And then the bottom one, because we want to make it have a 10, we're going to multiply the bottom by 5. So 5 times a -7 is a -35. 5 times 2 is 10y. 5 times 7 is 35. Combine those two together, the -6 and a -35 comes out to be a -41. Y's are long gone. 6 and 35 becomes 41. Divide by -41. And we find x to be -1. Okay. So then we need to find out what y is. So which equation would you like to use to solve for y? Top one or the bottom one? Got to pick one of the originals. The top one? Okay. So if we pick the top one, we're going to put a -1 in for x's. Three times a -1 is a -3. Add 3, and we find out that 5y is equal to 0. Divide by 5, so y is equal to 0. So if you get a 0 on top, that's what it means, is it's going to give you 0 in there. So, does it end up checking? So my point value I would put into Hawks for the answer for this is a -1, 0. Make sure you put your x first and your y second, and you will be good to go with that one. Okay, so does it check? 3 times a -1 is a -3. 5 times 0 is 0, so -3 and 0 is a -3. And -7 times 1 is a +7. 2 times 0 is 0, and I get 7, so we know it worked. There is absolutely no reason to get any of these wrong if you check them. So make sure you plug them back in, see if they work, okay? So make sure that you end up seeing what happens with that and what takes place with those. So, all right, what do you think? Yay or nay? Yay? Okay. One that has fractions, because once in a while they will toss one in for you that has a fraction in it, and I just wanted to put one of them in here so that we had an idea. Your best bet when you have a fraction is get rid of it. We've been getting rid of denominators for a long time in Chapter 7. So to get rid of this 2, what that would mean is I'd multiply everything in here by 2. So 2 times 3x is going to give me 6x. 2 times the 1/2, the 2's cancel, leaves me a -y. And 2 times 6 leaves me with 12. And so then if I bring the other equation over, what do you notice? They're the same, right? So if I went through to get rid of any of my variables in here, I would find that I have a true solution to this one. And I'd have multiple solutions. So there's not just one answer to it. So you'd have to select many solutions to it. So that's what you have to do with that one. If you put things together, and this is just an example, so you know what a non-solution one looks like that has no solution to it. If you had an equation such as a negative 6x, and we have solved, and we're going to solve for the variable x, and we've went through and we get all of our pieces together, what would happen with that is you would end up with something that looks like that. So if we said we're getting rid of x's, what will happen with it is all x's will disappear, all y's disappear, but when you do your numerical part, you're left with a number, or you're left with a false statement. 0 is not equal to 16. See how that's false? So if you run across this, and I'm not going to do a question that has one like it, but if this happens to you, so put it in your notes and note it as an example of a no solution, what you're going to find is that this will occur. They'll have a numerical value here, but it's false, so it won't equal each other. And so you've got something there that's not coming together. And so this one is a no solution. Same as this one was many solutions. So that's our two different special kinds. The other ones were conditional because they only had one answer. And so we have inconsistent and we have dependent. So this is also considered inconsistent. And this one's dependent. If you went back to the words from 8.1 within those. Okay, what do you think? All right. Decimals, if you run across ones that have decimals in it, you can get rid of those too. And you get rid of those by going to the farthest, the longest piece in here. This one's to the tenths, this one's to the hundredths. So this top piece, if you multiply everything by 100, your decimals would go away. So you would be left with 100x plus 40y is equal to 308. Do you need to do this? Not necessarily. You don't have to go through and change those. You can work with them as decimals if you want. Then the bottom one, because everybody's to the what spot? What's my farthest out decimal? Tenths. So 10. And so 10 times each one of these will leave me with x minus y equals 1. And so then you would solve it from there. It just really helps to make your math a little easier. Oh, yes, thank you. Yep, 10y. Because 10 times the 1 in there would have been 10y. Then you would have solved it. So I would have probably gotten rid of y's in here because that would be my common piece. So if I took the bottom one and multiplied it by 4, I could get rid of those. So 100x plus 40y is equal to 308. And multiply the 4 through would give me 4x minus 40 minus 4. And so I would end up with 96x is equal to 304. Divide by 96. 4 from 100. Because when I multiplied the top one by 100, I got 100x. You see? Oh, add it. Yes, yes. Thank you, thank you. Yes, I do add them. So it would be 104. So 304 divided by 104. And because I started in decimals, I will end in decimals. So what would be my decimal answer? So 304 divided by 104 would be what? Oh, should be 4. Boy, you're just catching me on everything. Thank you for catching me, though. That's good. 312 divided by 4. Now we get a nice even number of 3. So we get 3. So then, if I go back and finish solving it, what will I end up with for an answer for y? So I have 0.1 times 3 minus y equals 0.1. So I get 0.3. Subtract 0.3. Now I'm getting the right mood here. Minus y equals a negative 0.2. Divide by negative 1. So y will equal 0.2. And I shouldn't use green because it's probably not showing up for you in the back row back there with that. So that would be my answer. If you plugged them both in, do they work? 3 plus 0.2 times 0.4 is going to give me 0.08. 3 plus 0.08 does that. And down at the bottom, 0.3 minus 0.2 is 0.1. So we know it worked. So my point value with this one is 3, 0.2 for that one. Okay. But again, if you practice those, I think they come out a little easier than some other ones that we did with the first part of Chapter 8. This one is using systems to find equations of a line. The key in this one, it says use the formula of y equals mx plus b. This is the standard form, or this is the slope-intercept form. I'm going to go back to my black pen. That's the slope-intercept form for graphing lines. Find the equation of the line determined by the 2 points, 3, 5, and negative 6, 2. And what this means is when you rewrite these, and you'll run across some of these in your homework or in your sections there, write two equations in M and B by substituting the coordinates of the points in for X and Y. So if I go back up here to my slope-intercept form, 5 is Y, 3 is X, and B I don't know. And then the second one, 2 is Y, negative 6 is X, and M is my slope plus B. And so I have two systems of equations here. So then what I can do with these is then I can take those and end up solving those. And I think I've taken it to the back here and taken those two exact equations that we had. And now we can go through and use our systems of equations to solve it. So finish it. So what will M be and what will B be? So you guys finish it and see what happens. Pick a variable to make go away. Either one works nicely in here. Top one you'd have to multiply by 2 to make the M's go away. Bottom one you have to multiply by negative 1 if you want to make B's go away. So it's your choice. Can anybody figure out what M and B happen to be? So Cammie, did you get M? Did you get M? It's what was? 4? M is 4? Sure, M's 4? B is 4. Yeah, B's 4. M is still looking for M. Nick, what'd you get for M? Did you find an M? Gavin, what'd you get for M? 1/3. Beautiful. Yes. So if I take this thing off of freeze up here, then we'll get to see what was worked out in here. So I ended up getting rid of B for mine instead of getting rid of M. You may have worked out M first and ended up getting rid of it. But if you get rid of B, you find you end up with 3 is equal to 9M, because I need to multiply it through by -1. So -2, +6, and negative B. Add the two together and I get 1/3. Then I end up solving for B, and I find B is equal to 4. But instead of writing this in the value of 4, 1/3, if I go alphabetical, I don't want to do that. I want to plug these back into my y equals mx plus b, because I want an equation of my line. So to get my equation, then I want to plug those pieces back in for m and back in for b and come up with what my solution would be. Okay, I don't think I've got that off the page there for those. So that would be what you'd end up doing with that. So if you didn't work it out, you need to. Questions on this one? If you didn't solve it, figure out why. What happened? Did you not understand it? And figure out what's going on with those. So make sure that you're working on this stuff, because again, if you're thinking, oh, I'll just get some of my homework done, later on when you go home, you may not understand these. So put the homework stuff aside and concentrate on what we're learning in class, so that you're picking up on some of these things, because again, it just doesn't go away with those. So that's that one. So we've worked on one of those. And the last piece that they mention in here is deciding on which method, because we've got a bunch of different methods that we can end up doing with these. Whether you're going to use graphing. I can see that the only time you would probably use graphing is if you can, of course, figure out with your calculator what it's going to be, or if the problem asks you to graph, because usually graphing is kind of the more difficult of the three. Whether you're going to use substitution or addition. Substitution is if you got a variable by itself, or you can get a variable by itself, we'd use substitution. And addition, just kind of, you hop in and you just go at it. And you just get through it and you just make a variable disappear. So it depends on which one you're picking. When we get into 8.4, which is the story problems, we can choose whatever method we want to use to solve those with. So just keep that in mind, that you've got those combinations in here. So you can pick whichever one you want. If you use substitution and you've got a variable that has a 1 in front of it, why not? We can use it. If you have an addition one and you just want to make variables go away, that's your decision with those. And so again, it's just deciding on what method that you want to use to end up solving those and coming up with your solutions. I have some practice problems. I will go through, and these will be in the notes. So if you ever decide that you want to go back and look at the notes, they are posted in your in the Canvas for this class. In my online class, the full lecture is posted in there. And so again, these are in here as examples, and again, I'll work through those. Now, and then here's the answers that are for those. So if you wanted, you could pause the video and come up with those. So that's just in there. Now, there are 2 story problems that are in your packet that I handed out to you in class, and that's these 2. Because they do end up popping up in there. So in that handout, I think everybody's got one. You guys all have one in here? So you don't have to madly write these things down, and you got it right there in front of you, and we can go through and figure out what we do need to do with them, because these, again, will pop up in here, and it's the best idea to go through them and see what we can do with them. It says money is invested at 2 rates of interest. So with all of these story problems, we aren't limited to only one variable. We can use 2 variables. So we can let one be X and let the other one be Y. Or later on, if we've got something that has some meaning to it, we can go through and take a look at those too, and give them some meaning. It says money is invested at 2 interest rates, one at 9%, the other at 6%. If there is $500 more invested at 9% than at 6%, find the amount invested at each rate if the total annual interest received is $360. Let X equal the amount of the 9%. Let Y equal the amount of the 6%. So let's identify these. X is the 9%. Y is the 6%. So what does it tell us? It tells us up above that there is 500 more invested at 9% than at 6%. So what does that mean to you guys? So it means that Y plus 6 or plus 500, or is it X plus 500? Okay, Y plus 500 equals X. So the reason is that there's 500 more invested at 9%. The 9% is X, okay? So I would have to add 5 to whatever's invested at Y. So that's one equation. So I have one piece of my puzzle, okay? So that's one part of my equation. The second part involves this interest. So interest is what? What do we get when we get interest? Interest is the thing we earn on accounts. It'd be nice if we were earning that amount of money. Today it's pretty poor. If you have any money in the bank, it's like 0.01%. So you might as well put it in your, as they always say, stick it under your bed and add a quarter each month. You'll be making more money than having it in the bank. So, yes. Jay, you got a question?
If there's 500 more invested, 9%, 6%. Something like 6%. 500 more.
But it says if there's 500 more invested at 9% than at the 6%. 6% represents Y. So there's 500 more invested at X than at 6%. It's kind of backwards, but it's still meaning that you're putting $500 more in X. Once we know what Y is, let's just randomly say, let's say X is $1,000. What would be invested for Y? $500, okay? Because 500 plus 500 would give me my 1,000 invested at X. Does that help? Because it means you got more money in X's percent than you had in Y's amount. And because there is 500 more, meaning I need to add invested at 9% than at 6%. I need to add 500 more to the 6% to figure out what X is going to be. Is that helping?
I just have to understand that.
Yeah. Mm-hmm. Yeah. When you look at some of these, you might think that I need to reverse this because of where the more is at. Normally, when you would read this, you would say 500 more, so 500 plus the 9% is the 6. Yep, but you got to watch this then. Okay, then at 6%, it reverses your two pieces here. Okay, yeah. Yeah, it'll reverse the two pieces. And it's important to get that down because all the other ones that we got coming up in 8-4 are going to do that same kind of thing. They're going to all pull together and see what we have. So, so find the amount invested at each rate if the annual interest received is $360. Well, interest is based on the principal, which is X, and Y, times whatever its percent happens to be. So we don't know how much is invested at 9%, but we can turn our percentage back into a decimal, and you need to turn them into decimals to do these. And then finally for Y, it's 0.06. Y is equal to the total interest that the two accounts earned, which is $360. So these are my two statements. So if I have two statements like this, which method should I use to solve it? Which would you guys like to use? You want to graph it on your graphing calculator? No. I doubt if anybody in here would say, yeah, let's put it on there. The reason you would not want to graph this one is your window on your calculator won't fit it in there. Okay, so it's just easier to use the algebra to solve it. We could use substitution. That might be a wonderful way to do this one because we've got X already solved. Okay, and so again, on the story problems, you can choose whichever one you want to use. So if we've got it solved in here, we could plug in this value in for X and solve for Y. Or we could use what we just learned today, and that would mean I'd get all my variables on one side and my numbers on the other and come up with getting rid of a variable. Which is your choice? What would you guys want to do with this one? We kick graphing out. So substitution? Yes, we think? Or you want to use what we did today? You guys choose. That doesn't really make a difference to me. Substitution? Okay. So we can plug this back in where X is at. So we have 0.09 times Y plus 500 plus 0.06Y is equal to 360. If I do my multiplication, I get 0.09Y plus, and 0.09 times 500. What's that going to give me? Somebody out there's got the calculator. 75, you said? 45? Okay. Stick my Y's together. So that gives me 0.15Y plus 45 is equal to 360 minus 45. And 360 minus 45 leaves me with 315. Divide by 0.15. And we will find Y to equal, what was it again? 2100. Okay. So Y equals 2100. So that means at 6%, and on Hawks, when you get these, you will see two boxes. One box will say 9%, the other box will say 6%. Make sure you put your money in the right spot, okay? If you solve for Y, you would put 2,100 in for Y. And what did we invest for X? So go back to this equation, plug to 2,100 in, and we would find that at the other one, you've invested $2,600. Okay, does that make sense? Now, would it have made a difference if I used what we worked on today and used addition? Not at all. We still would have gotten the exact same answers. So the answers would be the same. Okay, but if you looked at this on your graphing calculator to do a graph with it, you got a pretty big graph. Okay, because you're looking at where these two crossed at, and that would be a gigantic one, and so it would be hard to fit that one in. Okay, last one for this section is another one of those Y equals mx plus b's, just so that we have an understanding what we got to do with those, because they tend to be the ones that slip you up when you get home. And I just wanted to make sure that we didn't get you all messed up with what we had to do with those. So what we have to do is replace your numbers. This again is x, the second one is y, and create your two equations. So we have 1 is equal to a negative m plus b. And the second equation, I have a negative 7 is equal to 8m plus b. And then from there, solve it and see what your values are. Again, choosing whatever method you want to use. Could we graph it? Probably, but you'd have to make sure you assigned m as being x and b as being y if you wanted to do that on your graphing calculator. It's just going to set your stuff up, and you have to be careful and make sure you put your stuff in there. If you use substitution, it would be a little bit more because I got to get a letter by itself. I don't have one by itself, okay? But if I use elimination or addition like we did today, I can get rid of my m's quite easily, or I could get rid of my b's. So whichever one you happen to choose that you want to get rid of and solve for b, and then plug those back in. So what's the answers to this one? So work it out, and I'm going to put this thing on freeze and work it out up here while you guys are working it out there. So you should have m equals a -1 and y, or and b equals 0. If you got those, is that what you got for yours? Hopefully. Yes, no, maybe. I ended up getting rid of b's, so I went through and multiplied by -1. It's changed everything, and I ended up doing my mistake here again. I didn't add these together, so it should be a 9 and a 9. And it should be a -8/9. So that changes things a lot. And then if I subtract 8/9 from both sides, I end up with 1/8 or 1/9. So a -8/9 minus or plus 1/9 b. Does that sound better to you guys? Hopefully, you should end up with those, because again, I didn't add my 1 and my 8 to get my 9m in there. So, okay, that's that section. Take a break. Be back at about 5 after. Should end up working, and then we'll take a look at more story problems, because that's what 8.4 is going to be all about. So get out, move around, come back. We'll work on setting these guys up. be good. 8.4 is looking at story problems. The whole section is story problems, just your favorite friends that you guys really like. These are going to be dealing with distance, rate, and time, but what makes them nice is we're no longer stuck with one variable. My basic algebra group today, they're going to be stuck with one variable, and we're doing story problems in there too. And so theirs is a little different than yours. And then there's number problems, and then there's amounts and cost. So those are the basic varieties that we're going to end up working with. And again, our objectives are to take linear equations and solve them from applied problems, which are distance, numbers, and the amounts and cost is what we're going to look at. So this one, just follow along for right now. Don't worry about taking some notes with some of these, because I know you don't have these written in your notes, but we're going to see if we can come up with an idea of how to make some of these work. And we'll do a couple of them that are in the notes part here, and then we'll flip back to your page that has your problems on it. So right now, just watch. You don't need to be writing stuff and so forth with that. It says a plane flew 300 miles in 2 hours. So we've got a distance and we have a time. Flying with the wind. So if it's flying with the wind, what does that mean? So start thinking of what does it mean. With the wind means the wind's pushing it along. It's going in the same direction as the flight goes. And so if you've ever been on an airplane flight and the pilot says, oh, we're getting in 10 minutes early, this is what you have happening to your plane. The wind is pushing it and making the plane go faster. On the return trip, flying against the wind, so now it's got a headwind and it's pushing it back. And these you don't like hearing when you're on a plane, because then the pilot comes on and says, we will arrive 15 minutes late to the terminal. And that's again because of the wind pushing the plane back, and it prevents it from moving as easily through the wind as it could with that one. And it traveled only 200 miles in 2 hours. So once again, we have a distance and we have a time in there. It says, what were the wind speed and the speed of the plane? So we have wind speed and we have the speed of the plane. So do I know either of those? Do I know the wind speed? No. Do I know the plane speed? No. So what those start to become is they become our variables. So the wind or the plane speed is S. The wind speed is W. And this is when you can get into assigning things a certain specific variable. And so they have more meaning to them. So when I get all done with my problem, if I have S solved, I know I have the speed of the plane. If I have W solved, I know I have the speed of the wind. If you get into using X's and Y's with these, it's sometimes hard to know which is which. You'll get the whole problem solved and say, oh yeah, I got X. What is X? Is X this one or is X the other one? But as soon as you say S, you know it's the speed of the plane. And write these down. Give these variables some meaning and put them on, like in your, when you're putting your notes together, put what that letter means. S is speed of the wind, W is the wind speed with those. The other thing you're going to want to do with these, and again, this is all written out in here, and we will chart and table the problems that you have in your problem samples. But it says when flying with the wind, the plane's actual rate will increase, so it's the speed plus W. When flying against the wind, the plane actually decreases, so its speed slows down. So we get S minus W in there. So the wind speed slows down. So you get some different changes happening in there. So what do we have? We've got rate times time equals distance. So if I look with the wind, my rate of speed is S plus W. It took time of 2 hours, and I ended up with what my distance happened to be. If I looked against the wind, the 2 hours, I ended up with this equation. Okay, so far so good of getting these things in place. So I've got that piece of information in there. So then what happens is if we go back to the other problem here, the other piece that we need to keep track of is with the wind, it could travel 300 miles. So this is with wind. 200 miles if the wind is against it. Okay, so if we take our rate times time is equal to the distance, we get our two pieces, but those two pieces are not fully put together until we end up taking them and putting them with what our distance is equal to. So with the wind was 300 miles it could travel. Against the wind, it could only travel 200 miles. And so we set up our equations in this manner. So now what happens is we need to solve it. So to solve it, multiply by 2 over here. So I have 2s plus 2w is equal to 300. And 2s minus 2w is equal to 200. And then with every one of these story problems, you can pick whatever method you'd like to use. Graphing, probably not. So we're not even probably going to look at graphing with any of these. We're going to look at either substitution or addition. So which would you like? Additions. Beautifully set up for addition, right? Because these w's are just going to whip right out of there and they're going to be gone. So I get 4s is equal to 500. Divide by 4. So I'll find out that s is equal to 4 goes into 500 once, goes into 10 twice, goes into, what, am I doing something wrong? I better take it over here. 500 divided by 4. 125 miles per hour is s. So what was s? The speed of the plane. And now we need to find out how fast that wind is blowing. So if I take this, plug it back into either equation, which one would you want to pick? So you kind of got to get a feel for these. And there's one that I would pick over the other. Which would you pick? The positive, yeah. The positive W. If you can stay away from these lovely little negatives because they're the ones that give you the most problems, if I can stay away from negatives, I will. So 2 times 125 plus 2W is equal to 300. So 2 times 125 is 250 plus 2W equals 300 minus 250. And I get 2W is equal to 50. Divide by 2. And I'm going to finally find W is equal to 25. So I found the two speeds that my wind would be going at. So my speeds are 125 and 25. To check it, plug it back in here. 2 times 125 is 250. Minus 2 times 25 is 50. 250 minus 50 will give me 200. So I know I did my problem correctly. Okay, so my speeds end up matching out. The other thing you want to make sure when you do these is that you have something that is similar and that your answer sounds reasonable because sometimes they don't end up sounding reasonable. Another one just to watch and follow along with, and again, you're going to have one of these in your sheet, so it's not like this one you have to busily write and everything, because we will go through another one that's like it, that's on your sheet. 2 buses leave a train station traveling in opposite directions. So sometimes drawing pictures ends up helping me with these two, because I can get to see that I'm at the train station, one bus goes this way and one bus goes this way. So again, I'm leaving it at different times. One leaves at noon. The second leaves at 1 p.m. So what happened to those buses? Well, if I read that line, one's leaving an hour later than the other bus, correct? Because if one leaves at noon, the other one leaves at 1, there's an hour's difference between each bus. So that's important because that figures into time. So we got to keep that in place there. The first one travels at an average speed of 55 miles per hour. So this is my rate. And the second one travels at 59 miles per hour. That's its rate. At what time will the buses be 226 miles apart? So what does that mean? Well, that means that this bus gets out here, this bus gets out there, and in between the two, there's 226 miles difference, okay? So if my distance is that, so one bus travels a certain distance and the other bus travels a certain distance. We good there? Okay, so one's going one way and one's going the other way, and this distance gets split between the two. So to cover this full distance, it's going to be bus 1 plus bus 2, okay, because they're traveling this distance and it gets added together. And that's important when you start looking at some of these, that you get that connection between the two. So now if we continue on, we're going to let the time of travel be x for bus 1 and y be the travel time for bus 2. So what did we know? Well, we know bus 1 was traveling at 55 miles per hour. Bus 2 was traveling at 59. The times are different, x and y. So x times y gives me what my distance would be, and 59 times y gives me my distance of my second bus. So what do we know? Well, from the hour amount, one bus was an hour faster, or an hour ahead of the other one. Remember how it said 1 hour, one leaves at noon and one leaves at 1? That's this piece. Bus X has been on the road already an hour compared to when bus Y leaves the station. And then you get the second one because both pieces of speeds, or the distance, or rate times time, is equal to 226. So that becomes our two equations, okay, out of that one. So we get the two equations, and then we would end up taking those two equations and solving them. So what method do you think we should use here if I've got two equations? We're not going to finish this one, but setting them up sometimes is the hardest part. So we've got substitution and we have elimination or addition. So which one would you want to use? Substitution, more than likely. This is already set up for substitution because it's got x all by itself. So then you would plug that back in. And I'll go back through and put the solution in here for this one with that one. But again, we're not going to take the time to do that because I'd like to get into setting up the problem so you can see those at least set up. In the solving, I think that part you're probably following along with those. The third type is number problems. The sum of two numbers is 80, and their difference is 10. What are the two numbers? So pretty straightforward with this one. Two numbers, so I got x and y, number 1 and number 2. So we've got x plus y is 80, and x minus y is 10. And again, to solve this one, what do you think we would use? The addition, because I can wipe my y's out pretty quick, okay? And end up with 2x equals 90, and we'd find out that x is equal to, x would equal 45. And so what would y be? So 45 plus y is 80. So 45 minus 45 from both sides. And we will find out that y is equal to 35. And sure enough, 45 minus 35 is 10. So I've got my two solutions in there for that one. Okay. Counting coins. And again, we will have more of these in your sheet. Coins, we've got nickels, and we have quarters, and they all equal $1.05. So Mike has $1.05 worth of change in nickels and quarters. If he has twice as many nickels as quarters, how many of each type of coin does he have? Two equations. One will be the number of coins. So how many coins does he have? Do we have any idea? Well, I know he has twice as many nickels as quarters. So if we make nickels equal to N and quarters equal to Q, we could end up figuring out what that happens to be. So it has twice as many nickels as quarters. So nickels, and this is again that backward one, Jay. It's kind of like that other one that we were looking at before, because it's got backwards pieces of saying it has twice as many nickels as quarters. So nickels would be 2 quarters, okay? So it's kind of that backward piece. And then you just got to go with what the worth is. And it says the values of the coin. So the value of a nickel is 5 cents, and the value of a quarter is 25. So we would just simply put 0.5 nickels plus 0.25 quarters is equal to $1.05. So the hardest part with this one is just getting this piece together and coming up with what that would be. So that would be our 2 equations. So we can end up counting out what those happen to be and coming up with that value for what our nickels and quarters would be. So then you'd have your equation that you'd work out. What method do you think we should use with this one? Probably, again, substitution. Could I get rid of my decimals in here? You bet. I would probably multiply everything by 100 and get rid of them. Then I don't have to worry about them. And then put my 2 quarters in for my nickel, and I would come up with what my solution would be for that one. Okay. And then calculating age. Kathy is 6 years older than her sister Sue. So what does that mean? So we've got K for Kathy, and Sue we're going to have as S. So what does that first line mean? And then it says in 3 years she will be twice as old as Sue. So how old is each girl now? So if K is Kathy and S is Sue, what could we find out? Kathy is 6 years older than her sister. Kathy equals 6 plus Sue, correct? We good there? Okay. And then it says in 3 years, she will be twice as old as Sue. So what does that mean? So that means K plus 3. So we're going to add 3 years to Kathy. But what's going to happen to Sue? It's going to be 2 times Sue. So Sue is right now 6 plus S. So Sue's going to be 6 plus X times 2 would end up being the formula or the equation for that one. And then we'd again substitute stuff back in for K and come up with what our values would be. Because if you're back here, we don't know how old Sue is in the first place. Okay? It says Kathy is 6 years older than her sister Sue. Okay? Yep. But in 3 years, she will be, in 3 years, if I add 3 years to Kathy's age, she will be twice as old as Sue.
You add 3 years of her current to Sue's age, multiply by 2, it equals Kathy's age plus 3.
So what were we saying? What did you say, Nick?
K plus 3, 2 times S plus 3.
S plus 3. Because up here we had the age that matched each other. Yes, thank you. S plus 3. Let's see if it works. We'll finish this one. So put this piece back in place. So we are going to substitute it in and get 6 plus S plus 3 is equal to 2S plus 6. So S plus 9 is equal to 2S plus 6 minus S minus 6. And we end up with 3 is equal to Sue's age. So if Sue is 3, make sure I did all my math right here. 9 is S, 2S and 6, minus an S and minus a 6, yes. Okay. So how old's Kathy?
You're slightly off the screen.
Oh, am I slightly off the screen? Oh, get it back on. Thanks. So if I put S back, or put 6 back in here, I get 6 plus S is 9. Okay, so now let's make sure that we are getting what we have here. So Kathy is going to be 9, and Sue is 3. So 9 plus 3 is 12, and 3 plus 3 is 6 times 2 is also 12. So we're ended up working out correctly. So we're good. Thanks for catching that one on me. I ended up doing that one. Okay. So that's what happens with that piece and coming up with it. So let's go and take a look at your sheets that you have and see if we can get some of these things set up for you, at least, if not end up solving them. So these, again, are a little bit different than the ones we just went through. But again, it gives you a good example of the different types that we have. So 2 trains leave St. Louis at the same time. One train travels east, the other travels west. The speed of the eastbound train is 8 miles greater than the speed of the westbound train. After 7 hours, they are 812 miles apart. Find the rate of each train. Assume that the trains travel in a single straight line in a directly opposite direction. So, what do we have happening? So if we chart this, rate times time is equal to distance. And we have eastbound and we have westbound. So we might want to use letters that represent these. So we'll make the eastbound E and the westbound W, because when I get all done, I will have what I need to have with these. So what do we know? It says one train travels east, the other travels west. The speed of the eastbound train is 8 miles per hour greater than the speed of the westbound train. So what does that mean? East. What do we know about the eastbound speed? 8 plus W. That is one of my equations. Okay, so this is one equation. The second equation I need to figure out from what they tell me. After traveling 7 hours, so who travels 7 hours? Do each trains travel 7 hours, or does only one train travel 7 hours? Both. So my time is 7. What do we know about their speed? Well, we know E and W will be our east and our west speed. So to equal the distance, we have 7E and we have 7 west. And if you look at both trains going, one's going west, one's going east, and the total distance in here that the 2 trains traveled is 812 miles. So if it's 812 miles, what are we going to end up having for that? So 7E plus 7 west is going to equal 812. And my other equation was E equals 8 plus W. So if we plug it in and solve it, we'd use probably substitution. So I have 7 times 8 plus W plus 7W equals 812. So 56 plus 7W plus 7W equals 812. Minus 56. And I find out that 14W is equal to, what's 14W going to be equal to? 812 minus 56. 756? Yes. Divide by 14. So W speed is going to be was it again? 54, okay. Miles per hour, and the east speed is 54 plus 8, because that's what we said east happened to be. And so 54 plus 8 leaves me with 62. So 62 miles per hour. Now, in your answer in Hawks, it will ask you to put in those speeds for the right train, so be careful. That's why we used E's and W's, not X's and Y's, because they don't have much meaning. So you want to make sure you give your variables some meaning when you work with those. Okay, the next problem. A small plane flew 375 miles in 25 hours with the wind. On the return trip against the wind, it traveled only 290 miles in 25 hours. Pretty strong wind. What were the wind velocity and the speed of the plane? Note the speed of the plane means how fast the plane is flying without wind. So what do we know? So if we have speed of the plane, and we're going to make that S, speed of the wind, and we're going to make that W. What would I know if I charted this stuff? So rate times time equals distance. So we have against wind, and we have with wind. So what is my time on these planes? So how much time are they traveling? Both 25 hours. What do we know about their rates? With the wind is S plus W. Against the wind is S minus W. We good there? Okay. So distance is going to be 25 times S plus W. And the other one's 25 plus S minus W. So our two equations are a little different. We don't have two separate pieces. These make two equations. So 2 times S plus W equals 375. I would not want to be on this plane. You'll find out if you solve it why you wouldn't want to be on this plane. Then, if we go with the other one, 2 times S minus W is equal to 290. We will end up with what our speeds of our planes happen to be. Do we need to finish it, or you guys can finish it on your own? What do you think? Okay. If you can finish it, any questions with that one? I don't want to send you out of here and not know what you're doing with these, okay, because story problems have a tendency to get that way. A flock of geese are flying with the wind, made a 440-mile trip in 8 hours. On the return trip against the wind, the flock traveled only 150 miles in 6 hours. This one's like the first one, like the one right above it. We need to go through it, or what do you think? Because it's basically like the other one, because you have the speed of the geese. We're going to make that G. And the wind, we're going to make that W. So if we have rate, time, and distance, we are going to have with wind and against. And so the rate is going to be G plus W and G minus W. And our time is, for the 440, it's 8 hours. And for the other one, it's 6. And our distance that they travel, that the goose traveled at this point, was 440 miles. And the other one was 150. So our two equations are 8 times G plus W equals 440. And the other one is 6 times G minus W equals 150. And then we can end up solving from there, okay, to get that one. Yay or nay? Okay. The sum of two numbers is 65 and their difference is 11. What are the two numbers? So this one you can use x and y. So x plus y is 65. And their difference means subtraction is x minus y is 11. And I think you're good on setting that one up. Yes? Okay. Another one with age. Jason is 11 years older than his sister Kate. So Jason equals Kate plus 11. In 6 years, he will be twice as old as Kate. So Jason plus 6 is equal to 2 of the K's. And I don't want to put my 10 plus or K plus 11 in there, so I want 2 K's. So that would be your one that you work with this one. And a substitution is probably another good one for that one. And again, I will finish these in your notes, so you'll have the problems worked out if you go back and make a copy of your notes that are posted in Canvas. Darlene has some dimes and quarters. If she has 16 coins worth a total of $2.35, how many of each type does she have? So dimes and quarters, so we got D for dimes, Q for quarters. This one's a little different than the example before because we know how many coins she has. So 16 is equal to dimes plus quarters. And then you want what they're worth. So dimes are 10 cents, quarters are 25. So if you removed your decimal, then what you would have is 10D plus 25Q is equal to 235. And that would get rid of your decimals in there, so you wouldn't have those anymore to work with. Okay or not okay? What you think? Okay. At least we got some good stuff going. And then it just gets into, again, more varieties. There's a whole bunch of different ones that are in here. Working her way through school, Diane works 2 part-time jobs for a total of 25 hours a week. Job A pays $4.50 per hour and job B pays $6.30 per hour. How many hours did she work at each job the week she was paid $137.70? I think she needs to find some better paying jobs. So you chart it again. If we chart this one, what do we know? Jobs are paid by hours and by the dollars for the job, and then by what we happen to have with that. So job A, job B, and we don't know how many hours, so we're going to make hours A and hours B. We know how much she earned per hour, $4.50 and $6.30. So what does that equal for take home? We had a total take home. So $4.50 times A plus $6.30 times B is equal to $137.70. That's one equation, but the total 25. So A plus B equals 25. So then we've got our 2 equations out of that one. Take a look at the rest of those that are in there. We're kind of running out of, well, I guess we could probably get a couple more in here of getting them set up. Alice travels 3 times as fast as Mike. Traveling in opposite directions, they are 192 miles apart after 4 hours. Find their rate of travel. That one's a little different. So we have Alice. We have Mike. Again, we need 2 equations out of here. One equation is going to be your miles. The other is going to be your hours. Or we've got to combine these into combining together in here. So Alice travels 3 times as fast as Mike. So what does that mean? Alice equals 3 Mikes. So 3 times M. And then they're traveling in opposite directions, and they are 192 miles apart after 4 hours. So 4 times Alice plus 4 times the speed Mike travels at is going to equal 192. So you've got your 2 separate equations in there because each are traveling 4 hours for those. This one relates back to those distance ones that we had earlier. It's kind of like that. The next one, Reggie makes a business trip of 288.5 miles. He averages 59 miles per hour on the first part of the trip and 47 miles per hour on the second. If the trip took 5.5 hours, how long did he travel at each rate? Anytime you have miles, anytime you have speed, it's a distance equals rate times time. And we have going, and we have heading home. 55 miles per hour on the first part, or 59, sorry, and 47 on the second part. How much time did he take? Now, if you're in basic algebra, we got to take these today and solve it using only x's, only one variables. You guys are lucky because we can put x, the amount of time going, and y, the second part of the trip, and make it y, and how long did it take. So the total trip, means 59x plus 47y will equal 288.5. And then the second piece is x plus y equals 5.5 hours. So that's where my 2 pieces come in at. And then cross off the furniture shop one. We don't do those anymore, so that one we can get rid of. Nope, they're not even in there. They won't even show up in your homework, so they won't even be in there. This one too, you can get rid of the hexagonal square, and that just leaves the length of a rectangle is 9 yards, and I think that one's not in there either. That one's in there? Is it? Okay, so let's do the rectangle length. These other furniture one and that other one I told you cross off won't show up anywhere in your homework. It says the length of a rectangle is 9 yards more than the width. So length, width. So what happens with these two? The length, so L of a rectangle is, keyword is means equals, 9 yards more than the width. So 9 plus W. So we got that piece. Then what is the perimeter formula? So perimeter equals, what's the usual formula for perimeter of a rectangle? Perimeter of a rectangle, want to count the outside edges of a rectangle? Perfect. 2W plus 2 lengths. Then all we need to get our other one is just put 194 is equal to 2L plus 2W. And then you can piece that one together at that point and end up solving it. Okay? So that's what happens with this piece. Okay. And then there was that one of the difference between two numbers is 26. And I think you can probably work that one out on your own. And again, story problems, take your time with them. If you run across any of them that you can't do, hit the send instructor and I'll help you over the weekend with those. Okay? But we got lots of samples in there. So make sure you pay close attention to those. And do not forget your graphing calculator next time, because we do need that.